Good morning, good afternoon, good evening, and welcome to the Spring Webinar Program. My name is Peter Humphrey. I work at Pivotal on the Spring team, and I am lucky enough to be joined today by Andreas Evers, Principal Consultant from Ordina Consulting. He is here to talk to you about some awesome tools to help you level up your Spring Cloud architecture. Things that their experience at Ordina have helped them operationalize and work with Spring Cloud technologies. Some great complementary stuff. So Andreas, very, very excited to have you on. Why don't you tell the audience a little bit about yourself and then get started.
All right, happy to be here. So let me introduce myself a little bit. So I'm Andreas. I'm a Java consultant for Ordina, and I'm really passionate about open source Spring ecosystem, but also like distributed computing, like microservices, the Netflix stack, all that kind of cool stuff. And we kind of have experience applying this to, on projects at clients, and we see that while the Spring Cloud stuff is really great, you still need some additional products to have a complete ecosystem. So we have seen a lot of talks about like cloud native architectures, like for instance the beautiful microservice from Dave Sire and Josh Long, but also his other workshop, Cloud Native Java, and also some other talks by, for instance, Kenny Bastani and some other guys who were talking about Spring Cloud, what the products were about, these projects, these open source projects, which were using Netflix OSS and other cool stuff. So I'm not going to talk about that specifically because you've seen these talks or you can see them online on YouTube. They're there. And actually what I want to have discussed today is what can be added on top of that stack. Okay, so the regular stack looks normally like this. You've got the Netflix OSS stack, which is wrapped in Spring Cloud. And in that stack, you've got, for instance, Zool, Eureka, Turbine, Hystrix, Atlas. And in the Spring Cloud stack, you've got, aside from the Netflix OSS, the config server, which is really awesome. The Zipkin project for distributed tracing with Sleuth. Well, Zipkin itself is from Twitter, but Sleuth is a great way to use it. And some other stuff like Stream and Dataflow and Task. So those things have been discussed already a lot, but we are actually going to step it up. We're going to level up this architecture with some extra tools. So here you can see that we added some libraries like Spring Cloud Contracts and REST docs, which can really help you test and document your services. Aside from that, we also will talk about tools like Spring Boot Admin and the Microservices dashboard for visualizing your architecture, for having monitoring. Some visualization services like wiremock and saboteur. Then we'll be talking about chaos, which will be very interesting. At least it really is to me, in the terms of Troublemaker, and then some logging and metrics, the ELK stack, Prometheus, and maybe some quality gate like Sonar, and some checks like OWASP and dependency checks and all that kind of stuff. Okay, that's what we're going to be talking about today. So the first thing, I really like Archer, by the way, so I'm going to be putting some Archer slides in here because I don't really like these boring topic titles slides. So this one is about monitoring, obviously, right? So the first thing we're going to kind of look at when we do monitoring in Spring Boot is Spring Boot Admin, because that's really complementary. So Spring Boot Admin is a tool from CodeCentric, which they have built to visualize all their services. Because if you have just one Spring Boot application in Monolith, it's really easy to have some basic understanding of what the service is doing, if it's up or down. But what if you have a lot of microservices out there? It's kind of hard to keep track of it. Spring Boot Admin actually uses the actuator endpoints, which can be plugged in by just adding a jar, adding a dependency to your POM file or your Gradle file, and you get some metrics exposed on your microservice. And Spring Boot Admin uses that and visualizes that in a very useful way. So it kind of looks like this. So you have a dashboard with your microservices listed there. You have nice integration in your browser with browser notifications. I'm actually going to show this live because that's more interesting, I think. Yeah, so actually I need to talk about this live demo environment because we have, I don't know if you can see this. Yeah. working. We have a demo environment from our newest client called TVH. They've really been very friendly in helping us set this up and lending us this entire environment for this webinar, which is awesome. Okay, so this is Spring Boot admin, and you can see here different details that you can consume or that you can actually check on your service. So you can see the gateway, Hystrix, admin panel itself, config server, the usual suspects, right? So let's take a look at the gateway, for instance. Here you got the gateway, you got some information, but this here is actually just the info endpoint from the actuator, but it's shown in a very user-friendly way. It also shows you the health information, which now has all these different ups. You can, of course, also check the JSON, but that's just not as nice. And it doesn't really, it's not that user-friendly. You can check memory information, JVM information, garbage collecting, and even Tomcat, which is running inside. So that's interesting, but what's even more user-friendly is the log file. So normally you'd have to look through an SSH or your server or whatever to get to your log file. That's not very useful. Here you can actually tail it from the UI. That's very interesting stuff. You can download it as well. You can't really search through the logs. You can't really visualize analytics based on the logs, but we'll get into that later. Same for the metrics. Here you can see counters and gauges, and they're also available in JSON formats from the actuator endpoints, but here they're really shown in an attractive way. You can see environment endpoints as well. So the ENP endpoint is here visualized, but the benefit here of having this is that you can actually change them on the fly. So you can change your environment endpoints or your environment properties by selecting a property here and changing it to whatever you want. I'm not going to do it here because I'm probably going to mess something up, but it is really user-friendly. Normally you would do this in a config server in a Git repository or something like that, but here you can do it in the scope of the lifecycle of the application. So if you restart the application, of course, your environment variables will be reset, but this allows you to be testing stuff like Hystrix, circuit breaker settings or something like that, and that's really useful. Then you have logging information, so user-friendly way of turning logs on or off, or to different levels. And instead of putting that in a logback file or something, which is then hard-coded in your application. I mean, you could do it with Spring Boot now with properties, but this is really a much more attractive way. This is using ambients, and of course, then you can see the ambients themselves as well. And you can even restart your application context. As you can see here, which I'm not going to do because it's the gateway. You can have a thread dump. You can see trace of what's going on in your application, which calls are entering your application. You can see the details of really what went on with these endpoints of yours. You can do a heap dump, which I'm obviously not going to do. And you can check some Hystrix, which is integrated now. So you don't even need the Hystrix dashboard. You can have it integrated in this application as well. So this might give you an idea of what's possible with Spring Boot admin. And the setup is just child's play. It's just adding, it's like a starter. It's just a regular starter. You have a vanilla Spring Boot application. You add a dependency, and you add an annotation to the application file. That's it. And it will boot up. And you will just be able to integrate with Eureka or any service discovery that you like. Okay, so that's, I'm going to switch to the slides back. That's Spring Boot admin. Okay, so next slide. So here you can see that this is has integration with Hystrix, but there's something important to know here that Hystrix only allows you to have only 5 connections tops with each Hystrix stream, because it's real time and it doesn't allow you to have too many consumers at the same time. It would really have an effect on the service itself, which it tries to avoid. So having it as part of your Spring Boot admin dashboard might be a problem if you have too many people looking at it at the same time. Okay, so you have to be wary. Okay, so we've been looking at some monitoring here, but what if we want to go deeper, right? What if we want to see some more visualization, some more analytics based on the logs or based on the metrics? Then we can look at Prometheus. Prometheus is something for metrics. It's really cool. It's been built by SoundCloud, and they started out with a monolith application. And back then, they didn't really need some advanced metric system. So they only used graphite and stat-z. But when they were moving towards microservices, because they obviously saw that you couldn't scale that well, or you couldn't go as fast to market with a monolith as you could with microservices, they kind of need a different system. They needed something with operational simplicity, right? They needed to be able to deploy this anywhere they wanted, whenever they wanted, and you didn't need to have a PhD to set it up. They also wanted to have a multidimensional data model so that they could slice and dice their data in multiple dimensions like host, service, endpoints, and all that kind of stuff. They also wanted to have scalable and decentralized system for independent and reliable monitoring, of course. So aside from that, they also wanted to have a query language, like PromQL, they called it, which allowed them to do visualizations and meaningful alerting. Okay, so that's what they came up with. It's Prometheus. And the first years, they didn't really announce it. It was open source, but they didn't publicly announce it. And the moment they announced it publicly, it really started to become really popular, as you can see with the GitHub stars. Now, if you want to know more about the history of Prometheus and what it can do, I suggest you check out the blog post. Well, I'll get into that later. First, I'll talk about the architecture a little bit more. So the architecture is basically you've got the Prometheus server, which integrates with services. It can do that with a service discovery, and it can then discover services which it has to scrape. So it will scrape metrics from these services, and it will do that in a certain interval. Once it has the metrics gathered, then it can visualize that in the web UI or in PromDash, which is now deprecated, so Grafana, which is really great for visualizing this stuff. You can also do alerting with an alert manager, and even if you have short-lived jobs that are shorter lived than the interval of scraping, you can use a push gateway. So all that stuff is available. So that's really powerful. So as I said, if you want to know more about this, check out this blog post. This is the link. Hold on. Here we go. Yeah, there it is. And if I switch to my screen share, okay, so here it is. You can actually, in the blog post, try it out yourself. Just clone the repository and, hold on, here it is. Clone the repository, use make, run make, and then you get a bunch of Docker containers, which boots up this entire system. You'll get some data already provided, generated, which then you can act upon. So this is a really nice way to test this out. I think there's like cats versus dogs idea, as you can see here. And then you can have different metrics exposed based on that. So that's very useful. It also has alerting built in. So if you want to try it out, give it a shot. Even Julius Foltz, the co-creator of Prometheus, pitched in on this, so it's definitely worth it. Okay, so maybe we can do a short demo here. Hold on, let me see. Okay, so I'm going to go to the Prometheus dashboard now. Well, obviously we have some metrics exposed by our service. This is our service here. It has a bunch of metrics. This is just basic actuator endpoint, but you can also have your own metrics exposed. Prometheus here. If you want to see how this is working, this is simply the only thing you have to do. I mean, this is on the internet. Just look for Spring Boot Prometheus, and you'll find a way to expose it. It uses the same metrics as before, but it shows it in a Prometheus way. Then Prometheus scrapes this. And for that, you can go to the Prometheus UI. As you can see here, you can have targets, and these targets here can then scrape your service, MS Rental. Okay, you can show these various. Well, you know what? Let me put on some metrics. Let me start the load test, and normally we should see some metrics coming in. So here you can already look for metrics like gauges. Execute this, and it should show once the traffic really gets scraped. Okay, now we will see this as well in Grafana. So you can also do alerting. Now there's nothing defined here because it's just a demo environment, but if you go through the tech block, you'll see a lot of alerting examples. Okay, so hold on. What's next? Yeah, let me take a look at Grafana. So Grafana then uses these metrics and shows it in the dashboard like this. I'm pretty sure you guys all saw Grafana before, but the integration is really simple, and it really supports PromQL, the query language from Prometheus, out of the box. So this is like a lot of CPU stuff, but what if you want to have some specific metrics for your application? You can do this as well, like this. So here you can see that we just generated some load, and we have some information here from the metrics that were exposed out of the box by Servo, which is also Spring Cloud now, supported by Spring Cloud. So here you can see these latencies, and that's really interesting because these are the 90th percentile. So if you would take 100% of all your calls, then the worst 10% are taking 4 milliseconds in this case. And on the right side, you can see that the worst call at all takes 40 milliseconds. So this is interesting. If you go back to the slides, hold on, switch the slides. There we go. For doing your history tuning, if you have this visualized like this, it's easy to tweak your circuit breakers, because what I always saw with clients is that they adopted Hystrix, but then when the first load test hit, they didn't really understand it very well, so they forced to close the circuits. Now, that's really bad, because that's like taking a circuit breaker and putting some nails into it and putting it into the wall. Right? So if your laundry machine blows up, then your whole house burns down. So that's really bad practice. But really, to tune your circuit breaker, you need to set all these settings specifically for your interaction that you're proxying. And one of the things you have to set is the retry mechanism. So it's a really interesting feature. If you have, you could really do a retry if a timeout is hit. So for instance, if you reach then the 99th percentile, which in our case was something like 14 milliseconds, you could say, okay, after it reaches 14 milliseconds, don't continue, just retry, and the chance that you'll end up in the 90% the next time is really big. So then you really cut off all these spikes that happen only in the worst 10%. Okay, so that's something which can really be useful to deduct out of your metrics. Okay, so let's continue. Yeah, so in Pivotal Cloud Foundry, let's say you're using Pivotal Cloud Foundry, it's also really interesting or easy to integrate it. It's just a matter of using a Prometheus exporter, which is supported out of the box, and you can scrape metrics from the deployments in PCF itself, so your application, but also from the Bosch metrics. So that's a useful way to also be able to visualize all that data, all these metrics from inside Pivotal Cloud Foundry. Okay, so I thought I would mention that as well. Then some alternatives here. You got Graphite, InfluxDB, and OpenTSBDB. There's a comparison website listed there if you want to know what's really the difference with Prometheus. But it really comes down to Prometheus being a full-blown solution, which is similar to New Relic and AppDynamics, but New Relic you have to pay for, and AppDynamics is like you got this free and premium model. So you should really compare those solutions. Okay, so let's continue. Okay, the ALK stack. So we talked about metrics. What about logs? We've seen some logs in the Spring Boot admin panel, but you couldn't really do much with that. The ALK stack, I think, is familiar to all of you guys. The ELK. It allows you to aggregate logs and then put them in an index DB like Elasticsearch, and then show them in a dashboard like Kibana. Okay, so it's really simple. The way it's set up. However, Beats and Logstash can be combined, but you could also use FluentD, or you could put a Redis in between, or you could use Kafka, all that stuff. But mostly what I've seen is that Elasticsearch and Kibana is default. So you could really have the aggregation differently, but Elasticsearch is kind of the default way of storing this information, and Kibana the default way of visualizing it. So let's have a look at how that looks. Hold on. Okay, so this is Kibana. Whoops. Okay, so here you can see a lot of logs coming in, but that's not really useful. You have to really have a query that specifies specifically what you want to see. So I haven't had lots of logs here lately. check a bit further down the road. Okay, so here you can see a bunch of logs. Interesting about this as well is that you can have here traces and spans. So if you're familiar with Sleuth and Zipkin project, the idea is from the Dapper, Google Dapper paper, where spans and traces are used to do distributed tracing. So traces are for the entire scope of the request, while spans are just for the component they're in at the moment. So you can also have traces added and spans as well. And then you can see correlations, as you can see here, between these different logs. So you can have logs over the entire span of the request. So that's an interesting thing to look at. And it's very well, I mean, it works out of the box. If you check the log message, it works out of the box like this. If you just use the default Spring Boot metrics. Okay, so you'll get this for free. Although you do have to add the Sleuth library to your dependencies. Okay, so let's get back to the slides. All right, so some alternatives. Splunk is a really great tool. I think it's the best one for log aggregation, but it does come at a cost. It's really expensive. However, if your company wants to pay for it, I think you should definitely go for it. You also have some other solutions, Sumo Logic or Papertrail or Graylog or others. And then there's of course the choice between SaaS hosted version or on-premise. So all this stuff you have to think about. If you use Pivotal Cloud Foundry, for instance, it's already provided out of the box. Okay, so the next thing we're going to talk about is about the problem of microservices and governance. Microservices is awesome for developers because it gives them complete freedom to do whatever they want. But that often doesn't really work in a governed enterprise. So all this revolution inside the development team or the DevOps team, it has to somehow be tracked or be kept under control, because the different stakeholders in the organization, they are not doing microservices. They're still thinking in their old ways, and you have to really comfort them. And doing that is something that that Spotify has really achieved. They've built System Z. It's not open sourced specifically for what they've done at Spotify. I suggest you check out that video. It's really awesome video about how they've visualized their entire architecture, but also organization. So which teams are doing what, are owning what, and also the dependencies between teams and between the different architectural components. And I think that's an important thing to have if you do microservices, because it's much more complicated than monolith. So when we actually look at the different stakeholders in the organization and we really want to give them peace of mind, you have to start looking at managers, right? So managers, they want to see what's the compliancy and the maturity of the services. They also want to have easy recruitment. They don't want to worry about 200 languages they have to find people for. They want to know what's the technical debt, where they have to chase teams. And, well, yeah, they have to chase teams. If budgets and priorities are in line with the architectural goals. Too many times have I seen a microservice architecture being rolled out and then not being invested into it enough, because the managers just think it's finished. That's something which is, I think, one of the most dangerous things about microservices in the enterprise. That if it comes from development teams, the initiative comes from the development teams, that your organization doesn't really want to change with it. Like, that's the whole DevOps thing, right? And that's very annoying for a developer like me. So also change management, we really have to have something for this. We have to know what's coming up. We have to visualize all this stuff, okay? So managers are worried, but also analysts. Analysts, they want to know what functionality you can reuse, what's out there, which resources are exposed, which events are exposed. They want to know the contents of these messages, of course, which services are impacted if they suggest change. They want to know which services they have to talk to. They also want to see which functional flows are available within the system. from front end all the way in the back end, in the databases. And also, not only what's coming up, but they also want to be able to define what's coming up. So other analysts will know as well that that this particular analyst is working on a certain functionality, that there's no duplication. And then last of all, we have the developers. They also are interested in certain stuff. Which versions are deployed where? They also want to see if those deployments that they make, if they are successful. Obviously, certain tools already do this, but if there's some hub which centralizes all this information, that would be great. They want to see which versions the dependencies have, and they want to see like this hub, like documentation, metrics, all this kind of stuff. They want to see in a central place. Or I mean, if that would be possible, that would be great. So we built something for this because there's nothing available for this currently. We built Microservices dashboard. It looks a lot like Spring Boot admin. It has the same kind of style. It also is auto configuration for Spring Boot. So you just have to add a dependency and an annotation, and it works out of the box. It also integrates with Eureka and all kinds of service discoveries, and it works in a reactive way. It currently uses RxJava, but we're in the process of changing it to Reactor because it actually supports Java 8 out of the box. So this dashboard, I can go through some slides, but I can also show it to you. If you go to the GitHub repository, you see a reference documentation there, and you can just boot it up from scratch, and then you'll have a couple of samples which already have some mock data, and you'll see just exactly this. I can do it now as well, but maybe I'll be out of time. I'm not sure. So you can do filtering. You have 4 columns, obviously, like UI components, like front ends, then resources or events that are exposed by microservices, the microservices themselves, and the backends. And as you can see here, you have this flow, this logical flow between the different layers of your architecture. And I think that's useful for analysts to know what's really what flows are out there and which teams or which impacts will exist when they make a change. Okay, so you can of course do filtering. You can also check some compliance measures. So the managers, they want to have some sense of compliancy, as I've said. Now, what if some of your teams are a bit lazy and don't want to implement certain stuff? We can visualize this by having certain rules implemented there. And that's giving a really great feedback to managers, because now they can see which microservices are not really compliant with what standards are. Of course, you don't want to restrict it too much because you want to have freedom inside your microservice. But certain things like a quality gate that has to be set up, I mean, that's kind of logical to have. So if you don't have that, then we can report on this and we can visualize this in the dashboard. So these kind of things are useful for managers as well. And then they know what kind of investment is still needed for the architecture. You can also add nodes. So while you have a bunch of nodes already generated based on what's out there in the ecosystem, now you can add a node. You can add information like there's an application being built right now which uses these different resources. It's very simple to do with virtual nodes, and other analysts will see it immediately that something is being built, and they won't try to build the same thing. I mean, if you're working closely together, this won't happen, but in big enterprises, this happens a lot. Same for microservices that you're going to create with bounded contexts. This gives you an idea of which bounded contexts are being built and that you don't overlap bounded contexts. Okay. So there's a bunch of documentation, a big reference guide. There's a Gitter channel. So I suggest if you're interested in this kind of stuff, give it a shot. It couldn't be easier. Let me quickly do a demo. So the dashboard here in our demo environment, which doesn't have a lot of services, it will first try to scrape or try to go into the ecosystem and retrieve all this kind of information. So here you can see that I've added a pizza resource, which is virtual because we don't do pizzas in our demo environment, but I actually show it now as if it's there. The moment that the pizza resource will be actually deployed on an environment, it will be replaced. The virtual one will be replaced with a real one. So this gives you great feedback. Okay, And in this case, we don't have any compliancy issues. Oh, we do, the Troublemaker. So here we can see that we couldn't call these actuator endpoints. They were blocked by authentication. So that's something that the dashboard wants to know in order to fetch all this information. So we've made a mistake there. So that's interesting to know that we still have work to do in this specific Troublemaker instance. Now we're going to be talking about Troublemaker in just a moment. Okay, so let me switch to the next item. All right, let's continue. All right, so now we see that a lot of things can be really kept under control by the dashboard, the Microservice dashboard, and having monitoring tools like Spring Boot Admin and AlexPack and Prometheus. But it doesn't always go like that. If you work with distributed computing, the first rule of distributed computing is don't do distributed computing because it's much harder than not doing it. So it would be logical not to do it, but it gives you great advantages that microservices offer. Like you can go much faster to production because you're much more decoupled, obviously. So when you're actually working in a distributed computing environment, a lot of things can go wrong, and the machines will take over your job because basically you're really the subject of the cloud, for instance, and the cloud will do whatever it wants. So this is the idea of the chaos monkey, right? The idea of having chaos introduced to the system. So we really have to, aside from introducing chaos, we really have to test if we have everything under control, if all our dependencies that we are calling have the right timeout set, all that kind of stuff. And we can do that with virtualizing. So I'll be talking about chaos in just a moment, but first let's try to test it up front before it goes to production. So a virtualization is something where you can pay a lot of money for, like with Parasoft, for instance, but it's also available open source free of charge. Tom Akehurst has built wiremock and saboteur. So wiremock you're probably familiar with, but saboteur is like something that most people don't even know about. But it's also pretty interesting. So let me just try to illustrate what's going on here when we use wiremock. So you have your Spring Boot application. It calls a service. Now, what we're going to do with wiremock, we're going to virtualize it. So we're going to have Spring Boot call this a virtual service, which is then wiremock. And in wiremock, we are able to set some faults. So what we can do with wiremock, we can say, okay, we're going to add a delay. So now, instead of returning right away this virtualized response, we're going to return it in like 10 seconds. But aside from that, you can also do some extra faults, like real problems, aside from delays. And there we can add just the 500, the server error, some random data we can send back. We can send back some malformed data or an empty response. And malformed data could be way too much data that the consumer could consume. So that's interesting stuff to make sure you're able to cope with this, because this could happen in the real world. And obviously, you don't always test for this, but you should. So this should be fine if you think that there's like there are no firewalls, let's say, because firewalls could still interrupt this. You could still have issues even if you test all this stuff. So let's take a look at saboteur then. Saboteur is a tool which is a hook into your system. It's a daemon on your host that can change the traffic control and IP tables. So IP table is a lot like a firewall, and if you mess around with that, you could really simulate a firewall behaving badly. And with the traffic control, you could say that the entire system is congested, or this entire network is congested. So what we could do here is we could also add a delay on that level, and we could also do some other faults, but complementary to the wiremock faults, like a total network partition, remote service not listening to a certain port that you need, packet loss, or a TCP connection timeout, so similar to a firewall. And we saw that once we wrote the wiremock tests, we were confident, but these saboteur tests still failed when we first introduced them. So that means that we didn't set the timeouts correctly. Now that's disturbing, because if you have a certain dependency, which your microservice is calling, and the dependency is taking a long time to respond, or has any of these 8 issues, or if you take delays as well, 9 issues, then you kind of have a cascading effect, a cascading failure. and you want to have an SLA on your service, on your microservice respected. But if you can't trust your dependency, then you can never uphold your own SLA. So having these tests in place allows you to make sure that your timeouts are on all the levels of TCP IP, okay, and HTTP as well. So not just a timeout on sending information over the wire, like actually sending the information, but also on the connection, also on the socket, all that kind of stuff. Okay, if you want to know more about this information, this kind of testing, definitely check out Christopher Beatty in his talk. Well, there's been more of them, but on DevOps was a nice one. 6 principles for building fault-tolerant microservices. Definitely check it out because it really goes in depth on these specific topics. Okay, it's also in the link section. I assume, or there are definitely other links there as well. Attachments and links in the webinar. You can check it out, and you can see these different links that I'll be talking about. Okay, so let's cause a little bit more chaos. The Simian army, right? Simian army from Netflix is the chaos monkey, or the gorilla monkey, or whatever, the chaos gorilla. These monkeys, they are very good at pulling plugs and making sure that something goes wrong on production. It's the idea of embracing failure. Now, that works well if you're on Amazon Web Services, but I've yet to see it at a real client working outside of Amazon. I've seen it in OpenShift. No, not on OpenShift, on Fabric 8, but it's really, I don't know if it's really working. But however, there's something which you can use instead, which is now Troublemaker. It's still a very young project, but it allows you to add a starter to your Spring Boot application, and then have a Troublemaker application running somewhere else, which then can call the endpoints exposed by this starter. And these endpoints are like kill or exception, this kind of stuff, or load or memory consumption. And this allows you to cause trouble at random times, at random microservices, on your dev environment, on your staging environment, or even on production. Okay, so these things are that's useful for making sure your developers have the right attitude, the right mindset. Because if this happens on dev all of the time, they will protect themselves because their tests will otherwise be failing constantly on dev. So that's the right mindset. And having Troublemaker really allows you to do this. So let me just give you a demo on this as well quickly. So here you can see Troublemaker dashboard. So you start the Troublemaker, and then you can kill a certain service like MS Rental here. So all these services are retrieved from Eureka or from any other service discovery that you plug in, and it will do so at random as well. So at 3 p.m. every day, it will select a random microservice, and it will kill it. Okay, I don't know if it's readable for everyone. Yeah, I suppose so. So once it's killed, it's important that it reboots like on its own, because in the cloud it could always go down at any moment, like the kettle and pets kind of thing. So that's a great test to cause chaos. Of course, you see sometimes that I have a failure because I didn't add a starter to this particular microservice. Okay, but if it chooses the right service, like here, it works perfectly. I mean, the service which has been instrumented by that starter. You could also add loads, which would just have 200 threads added to that service. And then you could even combine it with an exception or with memory consumption and with killing it. And you could see how all these different factors work together. You could have an exception, of course, manually thrown, which would be nice to see how the service reacts to a certain exception, how the circuit breakers of the consumer of that service react to an exception being thrown from that service. Or having memory consumption, that your entire heap is getting filled up, and then try to do some loads or try to kill it. And all this kind of stuff is useful for development, but also to make sure that people have the right mindset. Yeah, that's the idea about it. Okay, so let's go back to the slides. So that's chaos. Okay, so let's say you have chaos in production and on development. That's great, but you also want to have some kind of safety net up front. And we have a couple of tools that can assist in that. One of the tools is Spring Cloud Contract, which does, I don't know if you guys are familiar with contract testing and especially consumer-driven contract testing. I'll try to explain it here very shortly, but I suggest you guys go take a look in the links and attachment section for the webinar from Marcin, who actually built or open sourced Spring Cloud Contract, which is similar to Pact, but much more springy, which is great. So you have a consumer and a producer here, the producer, the factory guy, and the consumer, the little basket. Okay, so they call each other. The producer returns 10 properties, and the consumer only uses property 1 to 2. Okay. Now let's say you have 4 consumers, and they all use a different set of properties. Okay, I think that's pretty common. So let's take a look at the first one. What can we do to ensure that that the producer knows that the consumer only uses 1 and 2, and it cannot change 1 and 2, otherwise it will break the consumer. Okay, so the consumer walks towards the producer in terms of just cloning the repository, and it will write a contract. It will write a contract saying that consumer 1 uses property 1 and 2. Don't change property 1 and 2, producer, otherwise you will break me. Okay, so what then happens is that you have a certain Spring Cloud Contract verifier module that will build a jar out of this contract, and it will put it in Nexus or whatever repository factory that you're using. And then the consumer can then write an integration test, which then uses wiremock and uses the contract exposed by the producer as stubs. So now you have, aside from the contract, you have also automatic stubs in your consumer, which makes it easy to integrate. So the moment you have these integrations tests running well, you can add a PR for the contract. The contract can then be accepted by the producer. So the producer accepts it. He writes an integration test himself based on this contract, and of course many other contracts. So for all the different consumers, he'll have a contract. The benefit here is that you have the producer being certain that he will not break any consumers with a certain update, which is great because now he can see that if you look at if you remember the previous slide, property 1 to 10, not all of them were used. The last 5 properties were not used by any consumer, which means he can change them on like for free. He doesn't have to care about versioning. And the less versioning you have to do, the better, because it adds complexity. So this allows the producer to be more flexible. On the consumer side, this is the great benefit is that you can then be sure that you don't have any producers breaking you, and that you have stubs automatically generated. Okay, so this is great stuff as well. Then the next topic here, also for your safety net, Sonar Cube, OWASP, Find Segbugs, all this kind of stuff, like even dependency checker that can check your libraries that you're using for vulnerabilities. This is great to have this DevSecOps kind of idea, like shift left to the security. Don't do it in audits after like 6 months or then like only once a year. I mean, still audits are fine, but you have to have some kind of certainty that your application is secure. And making sure that's part of your build pipeline is great, because then you'll make sure that some of the vulnerabilities are definitely found out before you even go live, before you even deploy it. Of course, you can't find everything. That's why you still need to have some kind of security checks, probably manually or by some audit or whatever. But these kind of tools are useful. And Sonar Cube is more general, but it uses these kind of checks as well. So let me head on to the next part. So when we build these microservices, we have to be consumer driven. We have to think about consumers because they are the main stakeholders of the application and the reason why we're building it. So we need to make sure that our APIs are child's play, that there's really clear how to use the API and make sure that the API is never breaking any consumers. Okay, so how can we do that? Using Spring REST docs. It's been out there for quite a while now, but I think it can still use some attention because it's just super awesome way to document your services. And it's just, well, let me explain it. So first you write your integration test. This integration test then has some kind of an, you use, for instance, mock MVC. You can also use other ones, but if you use mock MVC, you can do and do, which is a hook. You can add something like some documentation hooks, which allow you to make sure that if your integration test passes, that you'll get some requests and responses from mock MVC, and you'll just take care of them. You'll just make sure you capture them, and you will put them to good use in these integration tests in the hook that is provided by mock MVC. Then, once you get all these request responses, this can generate snippets. And these snippets are just small pieces of code, of ASCII doc code, which can be used in a manually written template. So the template then talks about, for instance, how you should use in general your API, what's the API about, but not specifically about examples. If you want to have examples in your API documentation, that often gets out of date. Now, these snippets that are generated from your integration test, they are generated from mock MVC. So they're awesome to put into your manually written template because they'll always be up to date. Okay, so if you combine these two, Spring REST docs will generate an HTML. Okay, and let's take a look at how this HTML looks like. It looks like an ASCII doc file. Let's see, where do I have one? Here we go. So this is what it looks like. You can see resources here and the way to retrieve them, to store them, to update or delete them. And the good thing about it is that you get some examples. It's like this example request is just getting these orders. You can get the response structure also generated from your integration test and the example response like this. This is also generated. Let me show you in the code what it looks like. So here, I hope this is big enough for everyone. Maybe I should increase the font a little bit more. Okay, great. So here you can see that we have a bunch of tests, document orders, and you perform a post on orders. So a regular mock MVC test, and then you can do and do. And here you can say document under create order the request fields with the prefix requirements, which is not that important, response fields as well. So even here with parameters, you can do it as well with parameters. So this allows you to link documentation to your results of your test. And the documentation then is visible here. So the fields with pass ticket number, for instance, they are of type number, the JSON type, of course, and the description is like this. So if you have more specific descriptions, like the ticket number can only be 6-digit long and should only be numerical, it shouldn't be string or whatever, that's all clear. You can all describe this in the description. And then eventually it will generate snippets, and then you can get them as well in this document as well, here in the HTML. So that's a useful way of making sure that your documentation is always up to date, and you don't have to put annotations in your production code all over the place, which is kind of what tools like Swagger do. Okay, so let me switch back to the slide. We're almost out of time. So I wanted to talk about one more thing, something which is often overlooked, which is a great feature. It's part of Jackson. So you guys all know Jackson, I'm sure, but there's one feature called JSON views, which you probably, you might not have heard about. So here you have a car with a brand and doors, and you have a car controller, which is a get mapping. By the way, that's an alias for request mapping with path get, which is more concise, which is returning a BMW. Okay, so what can we do? We can say, I don't care about doors in certain scenarios. Okay, I only want to give back brand. So then you can say compact view with a marker annotation, and you can annotate the brand with compact view. So JSON view, compact view. So in case compact view is requested, you'll only get brand back. Okay, so if you then add an annotation on top of your controller method, you will get compact view. Well, you can say that this get mapping will return compact view from the Pojo. Okay, that's useful if you want to have different representations of your resource. But if you want to have versioning, then this is even more useful, because in versioning you often duplicate the Pojo, or you have different branches supporting different versions. Now you can just have annotations specifying which properties are for which version, and that allows you to make sure the complexity doesn't get out of the hand. So you have your car resource here with 2 different versions, and then you can have 2 different controller methods, which then have a different JSON view and which use content negotiation, which is pretty REST-like, I would say, with the different versions as media types. Okay, so that's how this works, and I think this, in combination with REST docs, can really give you a great feeling of how to use your API without having to resort to certain things like Bramble or to Swagger. And in combination with Spring Cloud Contract, you can lock this down and make sure that you know which versions are used where and how you have to interpret certain things if you're a consumer. So let's continue. So my last chapter here is about deploying all this stuff. So we had built our services, we had tested it, we had caused chaos. But what if we want to just deploy the stuff? We often use Jenkins, and then we write some Ansible scripts, or some Puppet, or Vagrant, or Chef. I mean, all these scripting tools, they start to live on their own, right? To become these little untested pieces of code that are difficult to debug. And wouldn't it be nice to have a UI for this, for deploying? Especially if you want to have multi-cloud deployments, multi-region deployments. That's it's getting difficult to do that in Ansible in a really nice way. So Netflix have actually built Spinnaker, and they've used Spring MVC and Spring Boot to do this, and Spring Batch to build Spinnaker. So most of their tools in the Netflix OSS are built from the ground up, but for Spinnaker, they thought, well, let's use something which, I mean, this is this bidirectional contribution. So they kind of use Spring Boot for an application that they've built now for deploying. It's actually the successor of what's it called? The one from Tor. I can't think of it now. Well, anyway, it's not the first time they've built something like this. So they've now took the entire application they've built before and restarted from scratch with Spring Boot. So how does it look like? It looks like this. So you can see your clusters, which are deployed currently. It's also cloud agnostic, so you don't really need to talk the specific cloud. The language of the specific clouds, like if you use AWS. It has the idea of load balancers and security groups and clusters. It doesn't always match with the cloud, but it's a great abstraction level. So you can have different types of cloud supported. You can have it on Google Cloud. You can have it on Azure, on Amazon. I mean, all the big ones. So you can see the clusters and what's actually deployed. You can also see pipelines, and this is the big strength of Spinnaker. So here you can do this, the next step where Jenkins left off. Right? Jenkins is great at building stuff, and they're not trying to rebuild Jenkins. They are integrating with Jenkins really well. So once your stuff is built, you have your container or you have whatever your delivery is, then you can take that and you can deploy it to the cloud in a very strategic way. You can do that with Highlander strategies or red-blue or blue-green, sorry. Or you can even have canary deployments and have tests based on what the canary results are. You can also do manual adjustments. Let's go over to my screen share for the final demo.
Andreas, it was Asgard was the name of the system you were trying to remember.
They wrote
it in, they wrote it in Groovy and Grails was their first one, and then the Spinnaker is sort of like the next iteration of that. It does a lot of what Asgard does, but it adds all this sort of CD tooling as well. Cool. Exactly.
Yeah, so that's what I'm going to show now. So for instance, our admin panel has a bunch of pipelines here. So we did it now with Docker, but you can do it with anything. you'd like, any containerization way, even with a jar file. So the Docker is getting triggered from, this pipeline is getting triggered from the Docker registry, and is then deploying it to dev. So how that works is, you can go into it, you can see that it's going to the Docker registry. It's taking the image that we look for based on some criteria, and then it's deploying it to dev. And eventually, after it's successful, it's destroying what was there before, so that we only have one version on dev. And you can follow along as well if a deployment happens, like what it all has to do. So if you have to do all this stuff with Ansible, that gets kind of tricky. So then you can, I can actually start it now with the latest version. I don't know if we can wrap this up quick enough. So it will start building. Then it has a manual verification where you can have a manual judgment. So if I would like to verify if everything is working accordingly in dev, I can do that, and then I can press a button, it's fine. Or you can have it automatically as well, that's also possible. But sometimes business wants to align this with some marketing campaign or something. Then for prod, for production, we find the image from the cluster. So that would also be some kind of a lot of scripting you have to do to find the right one from a running cluster. Then deploy that one to production, and then disable the previous one, so you can easily roll back. So not destroy this one, but just disable. So you can do the blue-green deployment if you'd like. So all this stuff is working pretty neatly. You could also do like some notifications. Can even do like different time frames where you want to deploy this stuff. You might not want to deploy every time frame. If there's like a deployment happening at night, it would not be very suitable because nobody's there. You might want to synchronize it with your office hours, or right before a certain peak happens. Like Netflix has this view of which what are the time frames when there's enough traffic or too much traffic, and then they avoid that in their deployments. So that's all kind of stuff you can do, which is pretty neat. Okay, so I think it's going to take too long to. Oh no, it's actually destroying the server group, and now it's going to ask me pretty soon to manually succeed this or cancel it. I think it should be only in a couple of seconds, and then I'll be able to push this to production as well. So you can go very far in this. Yeah, there it is. It succeeded, and now here I have manual judgment, and I can continue or stop. In this case, I can continue, and it will kick off the next deployment to prod. This looks really simple. It sounds a little bit like Jenkins pipelines, but it's really from the perspective of deployments of the CD part of your pipeline. So I think this is a very useful tool, and there's a lot of support for it in the community. It's not just Netflix, it's all the different cloud providers as well that are working on this, and Pivotal as well. So there's great integration with Pivotal Cloud Foundry as well out of the box. I mean, it's one-click deploy or something like that. So definitely check it out if you're interested in this. Okay, so
just so people realize, for any PCF users out there or Pivotal Cloud Foundry users out there, there's also there's a CD tool an open source CD tool that we've authored called Concourse, which is similar in concept to Spinnaker, but it's sort of less opinionated in terms of its pipelines. Spinnaker has a lot of opinions built into it, which is awesome. For people who those opinions don't work for, Concourse is sort of like a slightly lower level toolkit, but it's more flexible. So if the embedded opinions don't sort of work for you, you know what I mean, you have alternatives. Just so people realize. Cool. Hey, thanks, Andreas.
Yeah.
This is great.
Yeah, I heard a lot of great feedback on Concourse as well. So I think you should also compare the two and see which one fits best, right? I mean, that sounds logical. So, okay, if you are more interested in Spinnaker specifically, I suggest you check this talk from Amazon reInvent, which was a week ago, I think. And there's a great talk from Andy Glover, who's the lead of Spinnaker, and he really goes through all the different possibilities and capabilities of this tool. So if you want to dig more into that, then I suggest that's a great way to start. Okay, so to wrap up, we've talked about a lot of stuff here, as you can see. I hope some of the tools were new for you guys and might be interesting. I suggest you check it out. If you want to have more information about one of the tools, you can always check it. Let me know on Twitter, or yeah, then definitely we can see like also if there's new alternatives popping up, because every day there are new stuff coming out. This might also change this blueprint here. It's very pluggable as well, flexible. But I think this combination adds a lot of value to the existing Spring Cloud stack. And then if you compare it to Pivotal Cloud Foundry, because Cloud Foundry has a lot of these tools already out of the box, you can see a different picture, like this. So here we can see like Spring Cloud Services, which already offer Netflix OSS stuff out of the box. I know, Peter, if you want to pitch in there, like I think this, yeah.
Yeah, totally. There's some overlap in some places. The things that are highlighted in green are places where there really isn't any. But for people that are looking at Pivotal Web Services, which is our public cloud, or Pivotal Cloud Foundry, which is the on-premise, there's a bunch of machinery for doing microservice architectures like the Spring Cloud Services, where you can basically DevOps teams get a one-click install and fully managed Eureka configuration server and a Hystrix dashboard, and Cloud Foundry just like automatically provisions all this sort of the RabbitMQ transport, the Spring Cloud Stream transport for the Hystrix metrics, and even does like high availability configurations for Eureka and stuff like that. There's a really, really, really exciting roadmap for that, and I think a pretty unique offering for people that are looking at it. There's a few other places where there's some overlap. We're looking at, in the next release, we're looking at some of what the boot dashboard, or the boot admin, some of that, not all of it, but some of that will be integrated right into PCF. You can get right at actuator endpoints, for example, through the apps manager console, and then things like the ELK stack. Pivotal Cloud Foundry has a right out of the box tile for provisioning an entire ELK stack. There's some slight overlap with things Andreas, that you were talking about earlier with Prometheus and the Kibana aspects. There's PCF has a metrics capability where you can do like a time series correlation between logs where it's application events, container metrics, things like RAM, CPU, network, PCF system events, and correlate basically time series data to help you do that first responder type troubleshooting, like, oh gosh, something blew up, where did it blow up? So I can go, double click on it and drill in and try to resolve the problem.
Right.
You did mention, there's some preliminary integration with Spinnaker for Pivotal Cloud Foundry as well. And then, I think long term, we're looking at doing, we're really sort of trying to optimize in some ways for microservice platforms. Certainly can run monoliths, but we're even looking at Zipkin integration into PCF metrics, which is going to be great because so many devs like you need to see the call graph, right? You need to see how these things are going to exactly, and so we're going to be starting to integrate the Zipkin. Spring Cloud Sleuth is like the Spring client for Zipkin basically, and it's like we'll start integrating the trace and span IDs and allowing developers to actually visualize those and see where the life of a request as it spans multiple microservices. So we're really excited about that one too. And there's tons of great stuff coming up in the future. If you wouldn't mind going to the next slide.
Yeah, sure.
Just want to talk about that for a second, and then we'll get to some questions. So the Spring Cloud Services basically, like I said, it was the Eureka, the config server, and the Hystrix, sort of set up for you. It's not just the install and configuration and the security integration with Cloud Foundry's OAuth 2 server, but the nice bit about it is it's such a dramatically lower ops requirement, right? Since they are native Cloud Foundry services, when you think about it, if you're doing microservices, you're going to need to set up a lot of this support infrastructure, multiple config servers potentially, multiple Eurekas, multiple Hystrixes. And this just basically, not only eliminates all that setup, but it also uses Cloud Foundry to manage the service instances at runtime and over the life of the application, which is what's really powerful, right? So you get the 4 layers of availability, not only for your applications, but for the service, for those services as well. For not only for your microservices, but for the, for the Eureka, the Hystrix, the config server. If your app instance fails, PCF is going to restart it in a new Linux container. If a process fails, PCF is going to self-heal and restart the failed cluster components. If there's a VM level problem, it'll kill the VM and spin up a new identical one. And it can distribute even, your microservice instances across availability zones and stuff like that. So there's a really, really exciting roadmap here as well, looking at integrating HashiCorp for the config server, looking at similar types of integrations for Spring Cloud Data Flow, even Zool potentially off in the future, and having like provisioning Zool proxies per Eureka service instance. So some super cutting edge and exciting stuff we're really pumped about. So if Cloud Foundry is an option for you, there's a lot of sort of pre-work that you might have to kind of do yourself with the tools that Andreas was mentioning. That's sort of done for you. But there's also a really nice complement, I think. If we just go back one slide with a lot of these things like Saboteur, Troublemaker, wiremock, the dashboard. I mean, those are all sort of very complementary tools, and I think are great assets, for developers, regardless of their platform.
I think it shows that the Pivotal team has close collaboration with the Spring team, because I think that's obviously testament to what they've built. It's always the best way to integrate it is always in the Pivotal way, which is why they have this complete solution. But obviously that also works with our platforms, which is also great. So,
no doubt. Well, hey folks, if you liked what Andreas has had to say today, maybe drop him off some feedback and give him a couple stars if you appreciated the information today. And then we just have one question. There's already a couple people posting, hey, thank you, and that this was a great presentation. And now they have a lot of research and work to do.
Cool. Yeah.
One question directly to you, I think, is that if you're deploying microservices like the EC2 container service, and you're using Eureka to discover each other, how does the Spring Boot admin locate the services to access the individual boot actuator endpoints? Like, does that use Eureka as well?
Yeah. Well, there are 2 ways to do it. The easiest way is just to integrate with Eureka. You just add the service URL, the default service URL, like you would use it in the regular Spring Boot application. You put it as well in the application YAML or properties file, and it will out of the box integrate with an existing Eureka instance that you link towards. So that's working out of the box. You could also have another way of doing it and having a library, just a dependency, Maven dependency or Gradle dependency, into the different microservices, and have those microservices talk to the Spring Boot admin. So there's 2 ways of doing it, either discovering it through a service registry. By the way, it supports all kinds of service registries, not just Eureka, or having the applications talk towards the Spring Boot admin. And there was one more thing I wanted to mention as well about Spring Cloud Contracts just before we cut off. There's a really cool new feature coming up, or a set of features, pluggability it's called. And it allows you to have contracts set up in Pact, which is the leading consumer-driven contract testing framework for now. Have even PHP tests. You could write it in any language, and you could generate your stubs in, for instance, Hoverfly. So all this stuff is really cool, coming up in Spring Cloud Contracts. So if you're interested in that stuff, keep following it up.
Awesome. Hey, we're getting a lot of feedback from people giving you, 4 and 5 stars, saying, cleared up a lot of misconceptions, and, yeah. So thanks for that, and thanks for that, folks, and dropping off some feedback for Andreas. He worked hard to put all this together for you. I think that
it's like we do that at clients, right? So we see that we have different situations at every client, different setups, different cloud choices, whatever. And it's really every different, all these different scenarios, they really give us a great impression of what works and what doesn't. So yeah, that's really what we were trying to achieve. And I think it's also interesting for new folks. If you guys are interested in Spring Cloud and you happen to to live in Belgium, which probably you guys, not many of you are actually here, but definitely let us know. And there's tons of projects which we are doing, which uses these kind of technologies. So we need a lot of people to work on this stuff. So let us know then.
And are you guys hiring in Belgium?
Yeah, definitely. Even for the demo environments which I've shown, DVH, they're hiring as well, and we're trying to gather as many people who want to work on Spring Cloud and all these different technologies I've talked about today.
Super cool, super cool. Okay, and then actually one last question came in, and I think the webinar system actually is going to shut us down in just a couple minutes here, so we're going to have to wrap up. But he had one specific question on Spring REST docs, and I'm not sure if this is one you know off the top of your head, but we'll give it a shot. How does one manage to build the index for the Spring REST documentation HTML? And if that's not something you know off the top of your head, don't worry about it. We can post that to Twitter or something.
Yeah. Well, index, I don't know what really index you mean with index, but if it means like just an HTML or on the left side, the index, I mean, in any case, you can just check on YouTube and look for Spring REST docs, and there's tons of talks about this, which go step by step through the process. So you should be able to figure it out from there.
Yeah, I think you did. Was it you? I think it was you that did a talk on it at Spring One platform this past year. Is that right? Yeah. Cool. So that
online.
if you're looking,
you can check it out.
If you're looking for that, just go to spring.io/video, and that'll take you right to the YouTube channel and search for Spring REST docs, and you will find Andreas. Andreas's talk in high definition video from Spring One platform. Last question, I think, is are there any example blogs for wiremock? And that actually reminds me to tell people, check out the attachments and links section of your user interface. Andreas has put a ton of follow-up resources in there, and that will live on, on the Bright Talk syndication channel, so that you can come back to it later. It's not ephemeral; it doesn't disappear.
Just to answer this one really quickly, you have wiremock.org, and there's docs there, and they have really clear examples of how to use it. But I think there are tons of blogs out there, because this is a very well-known tool. Saboteur isn't, but wiremock is, and they work really well together. So give it a shot.
Cool. All right, I think that's it. We're about to run out of time. So hey, thanks so much, everyone. Really excited to bring this to you, and looking forward to joining you on the webinar program again in January. Stay tuned to spring.io /blog and our Twitter handle. And we will be announcing what the January Spring webinar is going to be. It's going to be, I'll give you a teaser, it's going to be Spring Boot related, which I think will be cool. And Andreas, thank you so much. It was really nice meeting you in person at Devox in Belgium. And I hope to see you there again and have you back on the webinar program in the future. Thank you very much.
Awesome.
All right. Have a great day, everyone, and happy holidays.
Bye, ciao.